Cindy's presentation title is Mass Customization, Implications and Implementation. Cindy has a BS from Texas Christian University in the United States and an MS and Ph.D. from Texas Women's University. She teaches in the Textile and Apparel Technology and Management Department at Cairo State University, and Cindy's research interests include 3D body scanning, rapid prototyping, mass customization, and sizing systems and standardization.
Good afternoon. We've all been faced with a few challenges today from the technology, and not unlike the challenges that the industry's been facing in the last few years. And so, as I follow on Brian, I have a few things to talk about that relate to what he had to say, plus talk about the challenges that technology might bring us with mass customization. We are all very good at doing mass production. In 1908, when Henry Ford first created the Model T, anybody could have one as long as they were prepared for it to be black. And we do that very well. And not everybody wants a black car. And so we've looked at a new idea of mass customization that Joseph Klein came up with for every other industry but the textile and apparel industry. And that basically is to develop and produce any product that a customer might want based on things we already do very well. And so what we want to look at today are some of the developing technologies that would support mass customization and how they might be implemented and some of the implications for implementing those. And some of those technologies are body scanning, apparel computer-aided design, textile computer-aided design, and digital printing. So the first one is 3D body scanning. Okay, there are a number of different body scan technologies available in the world today. I'm going to talk about 3 or 4 of them. The first one is the image twin or TC squared body scan. It's based on white light and phased profilometry. And it's a fairly inexpensive and fairly fast system to use for body scanning. It can be fairly small. The other one is the Fibre system. It's a laser scanning system, and it's one of the most expensive. It was first developed for the movie industry, for the movie Jurassic Park. And so their main focus has not been on apparel-related uses, but been on movie uses. And then the Wixon Wilson system was created in the UK. It creates color point clouds, so you see a color image of the person. It takes a bit longer for it to get that image and to process it, but it's fairly inexpensive and fairly small. And then the final system we want to talk about is the TechMap system. It's a German system, and it uses laser and creates point clouds and also extracts measurements. Of these 4 systems, the only one that was created specifically for the apparel industry was the image twin by TC squared. Now this is an example of what the scanning experience is like in a TC squared system. First, the lights are set up to have the best light reflection, since the point cloud is determined from how the light is reflected off the body. And then within 17 seconds, a scan of the whole body is taken and measurements can be extracted. We generally have our participants wear clothing that's close fitting so that we don't measure wrinkles and so that we don't measure constricted bodies. We try to have it be nice fitting but not tight. And from that scan, we get a 3D point cloud. Now, in the Wixon Wilson scan, you get a picture, a photographic image that you can turn around and you can tell who the person is. This particular image can be anonymous enough that nobody would actually have to know who the person was. But for the system to be able to describe or figure out what the measurements are of this body, they have to divide it into arms and legs and torso, so they know what the specific landmarks of the body are. And then from that, I hope it looks better. We can get 140 different measurements on the body. And those measurements should be able to be automatically transported to an apparel CAD system. But at the moment, most of those systems cannot accept those measurements automatically. The disadvantages of physical measurements are that mostly they're not accurate, and they can take as many as 4 hours to get all the measurements that are needed. So we move to apparel CAD systems. They're designed so that we can visualize the product, we visualize the garment, and we can use a variety of different products to do that. Gerber and Electra are two of the major industry CAD vendors, but also assist Investronica, Polytropon, CAD, and Wild Ginger, the companies that have products that can help in the visualization and the pattern garment design. We also use the systems to grade patterns and provide alterations of those garments. Does that look like a blank white screen? Sorry about that. It should be a beautiful marker. It's very dark with a regular. See, technology always provides a new challenge. We can also use it to virtually model what we want the garment to look like. We can apply the textile design in the shape of the garment. And then we can use it to drive an automatic cover. So it can be great technology if we can integrate all of it together. In the textile CAD area, we use computer-aided design to create the textile, either the print that will go on the surface, either the knit construction, the weave construction of the product. We use Adobe Photoshop a lot in NC State because it is widely available as a third-party software. But other important software would be InfoDesign, PointCorrect, Weave, and Sophist. And first we digitize or scan the images in and get them into some sort of visual library so that customers can pick and choose bits and pieces to create a whole textile design that they want before they find the product. And then the fourth technology that we want to integrate together would be digital inkjet printing. One of the first technologies out was the NCAD thermal inkjet printer, which was used for paper, and so was easily adapted, or not so easily adapted, but quickly adapted to textiles, based on the idea of heat pushing a little drop of ink out at a precise location. And then we have the Stork Amber, which is a piezoelectric printer, uses electrical charges to force a drop of ink out. And the third major technology is continuous inkjet printing. It's a little bit like a water hose that sprays the ink continuously and deflects a few drops towards the substrate as you need them. And the problem with this technology is that it requires continuously reusing the ink that's not being applied to the substrate, which means that ink has to be very refined. And it's an expensive technology, but very fast. So we could create hundreds of yards a minute rather than a yard and a half an hour. So in the digital printing, it gives us the opportunity of applying the design within the shape of the pattern and only printing exactly what we need and not wasting one bit of ink or fabric. We can reuse the fabric that's not being printed on. This particular garment could have been created specifically to the customer's measurement specifications from body scan. And we can do that now, it's just not automatic. It's a very time-consuming process. And then ultimately, we have to post-process the fabric that we print. It has to be steamed to set the color. We have the color reactive fiber, and we have to wash out the excess pad chemicals that have been padded to fabric and the excess dyes. So one of the ways we might look at implementing this would be we want to meet the needs of customers that currently aren't being met. We want to increase sales. And we want to reduce the huge dollars tied up in inventory. We want to avoid laying off employees. And we want to keep our factories open. And we want to make profit. And I'm suggesting that this is the way we have to do this to satisfy our customers. It's not the only way to do it. It might be in combination with mass production. Who would care about this? Well, suppliers for specialty markets would be the first group of people that would be interested, the first kinds of companies that would be interested in mass customization. That might be bridal, evening, tuxedos, anybody in large size market, small size, and prestige. The uniform industry for industry and sports, and protective clothing, where the fit is absolutely critical to the protection of the person wearing the clothing. And career wear and tailored suit manufacturers might benefit from this technology. So any manufacturer who attempts to clothe the customers with fit anomalies, which in effect is probably 98% of the population that don't fit in these current sizing systems, there's a large group of vendors out there that could benefit from this technology. Well, how will we implement it? First, you have to evaluate your target market and look for the opportunity. So we're going to do some planning, like Brian suggested. You want to gather information about how you can easily integrate that process into your current production practices, and then try to make alliances in industry with the people that can help you with your process. So plan the implementation. For this first step, you organize a customization team within your company. That means you have to be somebody from management invited into it, somebody from design, somebody from marketing, and somebody from production. And then you obtain the commitment of the team and all of those players that work with those people. And assign duties to those team members. Step 2. You have to get the team members trained to implement this, because most people aren't trained in mass customization activities. We're trained to be mass producers. And so we have to relearn how to alter products to fit people. We know how to make lots of distinct styles. We don't know how to change that. So the design team needs to learn how to set up their current products, which they already produce, so they can be customized. Production needs to learn how to integrate their custom production with their current mass production system. And then we go to step 3 and get all those elements in place. We establish industry alliances. We could get the production line organized and cross-trained so that we can move them quickly back and forth between the mass production activities and the customization activities. And then we prepare the products for customization. And that means, for example, a man's shirt, we have so many different collar types that you can have, so many different cuff types, so many different button choices. You decide exactly what the choices will be and get them aligned in the library for the customers to choose from, so that you allow customization, but within limits, the manageable customization. And then you organize the business process of managing custom business, which are really small orders. So order taking and order filling. And then you make sure you market the product to your customer, let them know that you have that opportunity, and you expect a fairly small return at first unless you do a huge marketing effort. So if although we're running it, we have great response, I guess. But Marks & Spencer, or Brooks Brothers in the U.S., just began their mass customization for men's shirts and tailored suits. And they didn't have a huge return on that for the first few months because basically they marketed it over the internet. So they needed to do some heavy hitting in all of the trade publications, on TV, and everywhere, but they weren't ready to meet that production level right at the beginning. So they started out slow, it had low expectations at the beginning, and it's increasing rapidly as time goes on. And then the fourth step is you launch the custom product, you give it 100% effort, you have reasonable expectations, and you continue to create other other products that can go into that custom line. And you manage the customer data for further study. So you never waste one bit of information that you get on your customers. It helps you plan even for mass-produced items that you carry at the same time. Some of the issues that you face with implementation. First of all, you need to understand completely what the technology is that you already have in place and that you already understand well, to find out what other technologies can currently integrate with that. And what do your industry partners have in place? Currently, in mass production, there are many companies that make a decision not to do business with somebody in another country because they don't have a system that will integrate with theirs. So in the U.S., if I've designed on Electra, and the company in Taiwan does not have an Electra system and Electra cutting, then I can't do business with them because I can't be sure that my information will transfer reasonably. So you have to do your homework to know who can you work with. And can you develop a way to integrate the processes? That may mean that can you get the vendor, Electra, can you get PC Squared, the people who create the technology to buy into helping you make sure it works? And do all the parties understand the importance of their success and the processes? Are they willing to give the effort and take maybe a little bit lower return at the beginning for future success? So some of the advantages of 3D body scanning, why we want to look at that as part of this whole technology and mass customization issue, would be because it's non-contact, it's very fast, it's highly accurate, it's consistently accurate. We can reproduce the data and go back and reuse the data as many times as we need to. And it can be integrated automatically. Some of the limitations of it currently are the cost of the technology, problems with missing data, which those problems can be reducing as time goes on. Some of those are due to shading and light reflection. Some of those related to absorption of light by the skin of the hair. Some of those are related to movement. Some of us have a hard time getting still for 17 seconds. And some are related to data processing or the algorithms that have been created to extract measurements. And some product considerations about what would be mass customizable. Is that product have customization potential? What are the design features, the fabrication, the fit issues? And we have to look at the fit elements that might ensure quality of the product. We have to be able to communicate fit and design opportunities to consumers, because that's one of the hardest things about making all of this work, is that the consumer understands what the fit is that they are asking for. So our considerations related to technology is how does it work? What's the information that's needed to make it successful? How can the process be managed between industry players? And do you make alliances with only those people who have complementary technology? Or do you take a risk on some of those who don't? Some of the issues are how will the measurements be obtained, body scanning or physical measuring, and what measurements are important to your product. We still have fabric preparation issues for digital printing, and we still have to physically produce the garments by hand. And those essentials for success is that we provide continued research to integrate the technologies, that we all have a desire to meet customers' needs. Rather, if our focus is more on the customer rather than on keeping our company in business, then we're more likely to stay successful. And that we have to be willing to accept and embrace change and have a commitment of management and all the other key players and knowledge and understanding of customization. Thank you.
We are out of time today, and I apologize for not having time for questions in the room. We obviously can have many questions and dialogue on the bus when we return to it. Thank you for your time this afternoon. you.